Hi everyone, my name is Emmanuel Obodo. I'm a specialist biomedical scientist and I'm also a lecturer in biomedical science here in the United Kingdom. I completed my PhD in biomedical science. For many years, I've helped a number of people to navigate through interview questions that help them to secure their dream job, either as a biomedical scientist or as a specialist biomedical scientist. And I'm here to help you to navigate interview questions, therefore increasing your chances of getting a job as a specialist biomedical scientist or as a biomedical scientist. I will ask that you like, share, comment, and subscribe to our pages. Thank you. Today we are going to be looking at full blood count laboratory result interpretation. Okay? Remember I had made a video on full blood count, MCV, MCHC, and also platelet and white cells. So today let's try to look at the possible laboratory full blood count result they can present to you during your interview, and then I will try to provide you the kind of answers and the way you should present your answers today. Okay, so this is scatter plot 1. Now let's look at this scatter plot. This one is mainly from 6mex analyzer, which we call maybe XN line. So another analyzer that you might get a scatter plot, another common analyzer here is Beckman-Coulter DXH800. Anyway, so you can see these different channels, like WNR is a channel that measures nucleated red cells and also total white cell count. Okay, you can also even to some extent measure maybe something like basophils, as the case may be. Then you can look at this WDF. You will see is a channel that measures mainly differentiated white cells. So that's why what I want you to pay attention is scatter plot. Okay, so this is scatter plot now for nucleated red cells, this is baso and so on. But the one I want to focus on, if you look at this WDF, this is the lymphocyte, this is monocyte, and this one is polynucleated cells like neutrophils. Okay, then these also polynucleated cells like eosinophils. So you can see how separate they are. This is what you want to see under normal scatter plot. Now, but sometimes when you start seeing scatter plot like this, okay, they can shift up. Sometimes when they shift up, okay, and sometimes they can become grayish. You start looking at something like a typical lymphocyte or lymphoblast or blast, as the case may be. So we're going to look at this more as I continue, as I show you other plots. Okay. So let's look at this. So this is a normal full blood count that has been performed. Okay. So this is XN line. Okay. So let's not worry about the result at the moment. But you're going to see the scatter plot. Okay. So this one that is, this one is the lymphocyte. Then the greenish one is the monocyte. Then this one is the neutrophils. Then this more reddish one you are seeing here is the eosinophils. Then another thing I want you to pay attention to when you look at a full blood count result, this is also important for people who are also working in the lab already. Okay, so when you look at a full blood count result and you see this kind of scatter plot, it says a lot. Another thing you then need to look at is the graph of the red blood cells. So you can see that this graph is normally distributed. Okay, that means that everything is fine. Okay, then the same thing is applicable with the platelet. It's also normally distributed. You can see the one peak. Okay, but if you see something like red blood cells and you have different peak, okay, it means something else. If you also have platelets showing you different peak, it means something else. We'll look at that in detail. So let's look at plot 3. So this plot 3 is a good example of normal graph you can see in differential count or platelet, as the case may be. Okay, so look at this. You see again, like I said, this is lymphocyte, this is monocyte, and this is neutrophils. Okay, this is also WNR. Remember we talked about measuring nucleated red cells as well. So if you look at this red blood cell, you're going to see that it's normally distributed. Everything is fine. Then the same thing is applicable with the platelet. Everything is fine. But look at the white cell count. You're going to see it has different peaks. Why? Because white cells comprises different types of white cells like neutrophils, monocyte, lymphocyte. So that's why you can have that different peaks. Okay, good. So that is normal when it talks about when you look at white cells, but white cells are measuring other type of white cell as well. There's other type of white cell in it. So that's why you have different peaks. So let's look at something as like plot 4. So if you look at this plot 4, you are going to see that this is a differential channel, white cell differential channel. So it shows you that under the normal condition, you're going to see lymphocytes here, you see neutrophils here, you see eosinophils here, okay? Then if it is left shift of neutrophils, it can extend to this place, okay? But when you start seeing when you start seeing lymphocytes, instead of being here, it run up to this place, you now know that you should be expecting a typical lymphocyte, okay? Now, if it runs from here and up to here as well, you might be looking at lymphoblast as the case may be. Now, if it is monoblast, you're going to see something like this place shifting up to this point, okay? So this is some of the things you need to also understand, especially if you're also working in the lab. This is not just for people looking for a job, okay? This is also for people who are already working in the lab. So you put all this into consideration before making a decision. Now, let's look at this. This is a typical example of what I was going to explain to you. So you can see this is a normal differential scatter plot. You can see this is very clear. This is lymphocyte, this is monocyte, this is neutrophils, and this is eosinophils. So this is just normal. But what I want you to look at this one. Look at this. You see that this is a lymphoblast. So look at this is a lymphocyte. So this is also a lymphocyte, but it has shifted up. Look at it shifted up, okay? And not just that it shifted up, you are going to see that it is now grayish in color, okay? Very clear grayish in color. When you see something like this, start suspecting lymphoblast. Very, very important. So when you see something like this, it's already showing you there's a problem, okay? Then you investigate further, okay? Now, the same thing is applicable here. So you can see again, okay, you can also see that this is also lymphocyte. This is also lymphocyte. So in this lymphocyte now, you see that again, the same thing happened, but not as big as this one, but also it indicates there's a problem, okay? You investigate that further. Now, look at this other one. So we've already explained this. We've also explained this, okay? So this is now a kind of myeloblast. So basically, once you look at the differential count, okay, and you look at the scatter plot, you are seeing something like this grayish color is a problem. So start suspecting possibility of blast, and that need to be investigated. That means something is not right, okay? That need to be investigated. And in the lab, what we normally do is to remove that differential count that the analyzer has given because of this kind of thing. Then when you remove it, you can then do the differential count manually. So this is a key parameter that I want you guys to look at. Once you go for interview and they present a full blood count result, guys, you don't need to look at all the parameters. It's not like all the parameters are important, but it also comes with experience. Just make sure you look at the white cells, look at the hemoglobin, look at the MCV, look at the MCHC, look at the platelet, then look at the neutrophils. You can then also look at other differential count depending on the result of the total white cell count. This is very, very important, okay? So let's look at this result. So this is case 1. So we're going to start looking at cases. So look at this case 1. In this case 1, you're going to see that I've given you possible things you can think about here. But I want you to look at this. What is the problem here? There's a lot of problem here. The total white cell count is low. Of course, the red blood cell is low. Hemoglobin is low. Hematocrit is low. But something like MCV is normal, okay? Then you look at MCHC, is a little bit high as well. The platelet count is very low, and of course there's a neutropenia, okay? These are problems, okay? But meaning that when you see this kind of result, it means that one, it could be leukemia, because in terms of maybe something like somebody who is already on chemotherapy, it attacks the white cells. So this result can be common to someone who have got maybe AML and the person is on chemotherapy. So you are going to see that because of that, it will attack the white cells, and that's why the total white cell count is low. Even the platelet count is low, hemoglobin is low, and the neutrophils is low. This is a typical kind of result you will get in terms of someone who has one leukemia like AML. Now, what did that mean that there's a leukopenia, meaning low white cell count, there's neutropenia, meaning low neutrophils. Of course, there's anemia because the hemoglobin, red cells, hematocrit, they are very low. Okay, that's anemia. But because of the MCV is normal, we call it normocytic anemia. Okay, then of course there is raised MCHC. So these are the possible things this result can show. But can I tell you that this result, I left it towards the end, is none of this. So this result was a diluted sample. This sample was taken from a drip line, okay, like I've explained in my previous video. So that drip has diluted the sample, and that's why you're having this kind of result. Remember, I told you, whenever you go for interview question and they give you a platelet count that is very low, a platelet count, hemoglobin that is also very low, start thinking about diluted sample. It does not mean that you cannot mention some of these things that I've just said. So that's why I left the answers on the corner for you as well. Now let's look at the next case, which is case 2. So if you look at the case 2, you are going to see that there are many things to consider here. There is mild leukopenia, meaning that the total white cell count is a little bit low, okay? And of course, the hemoglobin is 91, which also means that it is low, okay? And the MCV is normal, which again indicates normocytic anemia. But there is so if you go for interview and they show you this kind of result, even though you may comment this thing I've said, that is not what they are looking for. Let me give you the secret. So when they give you a result, please look at the previous. So look at the previous. If you look at the previous day, it says 0.0000000. What it means that sample was done. So this was the previous result. So look at the previous result on this line. Hemoglobin previously was 51, okay, and so on. So these are the previous result, and it's saying that this previous result was done today. That's why you have 0 day. If it was done yesterday, it will be 11111. If it was done 2 days ago, it will be 2222. So whenever you go for interview and they present a full blood count result for you, please look at the previous. They will always going to put that previous. If they don't put the previous, that is fine. Still comment on the things I'm going to be showing you. But if they show you the previous, they want you to compare the two. So when you compare this, so this person has 51 today, and the same today is now hemoglobin of 91. What does it mean? So that's the answer I have ticked good for you. It means post-transfusion sample, meaning that this person has been transfused. Okay, this person has been transfused. Let me also give you another secret. So if it was 51, you can even gauge the possible amount of units this patient has had. 1 unit of red blood cells, okay, will increase the hemoglobin by 10. Okay, so if it was 51, okay, you might even start guessing that this person had up to 3 units. Some have approximately 3 units. So this is also what you can even tell them if you want, okay? But anyway, this result indicates post-transfusion. So when you see it, you look at it previously, okay, now, okay, that can be post-transfusion. If this person has not been transfused and it's on the same day, please, it then means that there is something wrong either with the previous result or the current result. So the question is then, is the previous result clotted, or is it diluted, as the case may be, or is the current result actually the result of the patient? So again, that could also indicate that. But anyway, on this occasion, is post-transfusion. This person has been transfused. Now let's look at case number 3. If you look at case number 3, so very, very important. What you are going to realize is that you could question post-transfusion because the hemoglobin previously was 51. Now it is 136. And with previous, like we've said, we are saying today is less than 1 day today. And there is no any way the hemoglobin will shoot from 51. Remember what I told you, each red cells can increase the hemoglobin by 10. I want you to subtract 135 from 51. You can imagine how many units you can possibly assume this person has had. And that is not possible, because that might lead to what we call TACO. Okay, so which means it has to do the kind of hazard, okay, during transfusion overload. Okay, but that's by the way, I'm not gonna bother you with that terminology. So now, because of that, it is very wrong to think that this person has been transfused, even though it might show that yes, possibly this person has been transfused, but on this occasion, no. Looking at the fact that this has shoot up very high. Okay, 136 is very high. So possibly this is actually a wrong sample in tube on this occasion. Meaning this current result is not the patient, it's another patient. Very important. If in any situation is not the case, that means there's something wrong with the previous result or the current result. So one of them, either the previous or the current, is wrong patient in tube. So that is one of the answers you can give to them. So one of the things I'm trying to teach you guys is that when you give answer, please don't rush it. Take your time. Give detailed answer. You see how I'm telling you other things that could lead to that, and also giving you what finally is the problem. Okay? Now let's look at the next one. This is very important. So if you look at this result, one of the things I would like to start off with before I continue, anytime they present a result to you and you see this data check, okay, this triangle shape you are seeing here is called data check. Whenever you see it on full block count result, it means it has failed the data check. Let me explain data check for you. It means that it has, when you compare the previous result with the current result, the difference is high. So it's questioning, is it a right result for this patient? That's data check. Okay? So once you see that, your eye should go on that place it failed, and you ask yourself, what is the problem? So obviously, our problem here is that it failed on the platelet count. Platelet count is 75. Okay? Now, but previously, which was the same day, the platelet count was 238. So what is the problem of this? The sample is clotted. But don't forget, don't be deceived. You might expect this is based on experience. Sometimes, even when sample is clotted, it may not necessarily affect the hemoglobin, but definitely it will affect the platelet count. And I've explained it during the platelet count video. So anyway, this sample is clotted, but again, this result could indicate when you compare it from the previous that it could be a wrong sample in tube, okay? It could be thrombocytopenia, or it could be bleeding, meaning that this person may be bleeding, and that's why the platelet count has been activated, and that's why possibly it is low. But once again, this result is a clotted sample, okay? Now, let's look at this one, okay? Case number 5. One of the things I want to show you here, the main thing I really want to show you here is not the parameters. The main thing I really want to show you here is this place that is circled. So you can see that this place that is circled is the red blood cell distribution. So it's supposed to have a normal distribution. Don't forget what I showed you before. But if you look at it, you're going to see there's about 2 peaks. There's 1 peak, there's 2 peaks. So there's 2 peaks, meaning that there are 2 populations of the red cells. So because of that 2 population of the red cells, you call this very red blood cell distribution dimorphic, meaning there are 2 populations of the red blood cell. And what does dimorphic mean? What does it really indicate in most cases? It might indicate that this patient has been transfused. So if the patient has been transfused, that means there's a mixture of the patient's red blood cell distribution and the donor's red cell that was transfused distribution. So because of that 2 peak, it indicates inside the patient there is 2 red blood cell distribution, the patient and the donor. Okay? So that's why you see that. That's dimorphic. Now let's look at another one. So if you look at it, this is one of the things. Remember what I told you about cold agglutinates, okay? So look at this, very, very important. You're going to see, what I want you to notice, remember I told you that high MCHC can indicate cold agglutinate, okay? And I also told you it can also indicate lipemic sample of hereditary spherocytosis. But on this occasion, it's actually cold agglutinate. What I want you to note is the first run and the second run. So if you look at the first run, you are getting like 900 and something. But if you look at the second run, it is now corrected. It has now come back to normal. So that's why it is circled. So if you look at the first run and the second run, you see the difference. So why is that different? What I want to tell you, they show you this kind of thing during your interview. Tell them that the first run, that the MCHC is high, and which can indicate cold agglutinin. And this sample has been warmed up, maybe using incubator, or using water bath, or using heat block. Remember what I told you about raised MCHC. So, and I'm following the warming of that, okay, then it's now correct. And because it's correct, it's a strong indication that this is cold agglutinin, meaning this patient has cold agglutinin. If you have not watched my video on raised MCHC, you go and watch it, then this is properly explained. But yeah, this is a typical example of cold agglutinin, okay? This is a typical example. Now, let's look at case number 7. One of the things I want to show you on case number 7 is not to look at all the parameters. We've been looking at all the parameters here. So I'm going to focus on, if you look at this differential, everything, the analyzer was not able to measure anything. Then look at this scatter plot, is not able to, everything is just scattered. Okay? When you see something like this, it indicates heated sample. The sample has been overheated. Let me tell you a good example where this thing happened. In the United Kingdom, we have what we call GP, okay, which is a local kind of clinic or hospital, around wherever you live. So if you are feeling sick, you go to the GP and they collect your sample or something like that. Then that sample needs to be transported to the main hospital that will analyze it. So what happens when the transporters come, they pick it, especially during summer, and they may leave it in their van. And that hot temperature, the van is very hot, and that can overheat the sample. That before it gets to the lab, that sample is already overheated, and that's why you can get this kind of result. Or you can also get this kind of result when maybe in terms of code and clothing, and for some reason you just overheat the sample, and of course this can also happen. So that's what has happened here. So let's look at this one. If you look at this one, you are going to see that in case number 8, what I really want you to pay attention is the nucleated red cells. There's so many things that this thing means, which I have shown you. Mild leukocytosis, meaning that the leukocyte is slightly high. Mild neutrophilia, meaning that the neutrophils is slightly high. So meaning that the thrombocyte is slightly high. Then anemia, macrocytic, because the MCV is raised, okay? Then you can have a mild monocytosis. That's one of the things you can explain to them. But the main thing about this result is that the nucleated red blood cells is high. And when nucleated red blood cell is high, what does it indicate? What can be affected? Remember, red blood cells should not have nucleus. They shouldn't. Mature red cells should not have nucleus. But when they have nucleus, because it will have one nucleus, I want you to think about other white cells. Something like lymphocyte has one nucleus. Something like monocyte, one nucleus. So meaning monocyte and lymphocyte, they are mononucleated cells, meaning they have one nucleus. If there is high nucleated red cells, it will mess up the lymphocyte and monocyte count. On this occasion, it messes up the monocyte count. And what are you going to do when you see high nucleated red blood cells? What you do then is that you take off the differential count, then do it manually, because that's where you're going to notice that high monocyte was due to nucleated red blood cells. So let's look at case number 9. In case number 9, what you are going to see here is that it is mostly old sample. Remember what I told you about old sample? In old sample, you are going to see that the scatter plot, they will all stay together. The scatter plot will stay together. It will not spread like I showed you in the previous. So once you do a full blood count and you see that the scatter plot has stayed together, please start thinking about old sample. And don't forget what I told you about race MCV. I told you race MCV. If you have not watched it again, go and watch my previous video on that. Race MCV can also show you of old samples. This is also a typical example. Once it is old sample, the MCV will be high. Okay, this is also one of the examples you can get there, and that's why you're getting raised MCH as well and low MCH. So this is definitely old sample. What do I mean by old sample? A sample was taken today, they didn't bring it in the lab today. After 2-3 days, they bring it in the lab. That is the problem. That is the kind of thing you are going to see. The giveaway indication is a scatter plot. Look at it. Everything stayed together, and look at MCV high and so on. Okay. Now, let's look at this one again. This is also meaning that there's an anemia, meaning that the hemoglobin is low, like you can see there. So once this happens, one of the things I really want you to know is that you can see that this indicates that this person is anemic, but the MCV is normal, meaning normocytic anemia. But on this occasion, once again, look at the previous. Today, 74, now still today, 91. This is a post-transfusion full blood count result. So meaning that this person has been transfused, and that's why the hemoglobin has increased. So this is a post-transfusion result. Now, having known that, let's look at case number 11. In case number 11, you are going to see what I would really want you to pay attention here is wrong sample in tube. This is one of the commonest questions they ask. If you have not watched the video again on MCV, go and watch it. Because if you look at this, you will see that MCV now is 68, if I can see it correctly, or 66, but previously it was 76. Just 3 days ago, that's why I pointed it, because I don't think it's clear. Just 3 days ago, so it has changed from 76 to 68. That is significantly high. And I told you, MCV hardly change. When you see something like this, tell them this could be due to wrong sample in tube, meaning it is not the patient sample. That is a strong indication. MCV hardly changed within a short period of time, and I told you the only thing that can change it. You can watch the video for more information. But again, it doesn't stop you from commenting about the sample is what anemic, okay, and this anemic because of the MCV is low could be microcytic anemia. You can comment that, but please tell them this is wrong sample into because the MCV have significantly changed within a short period of time. Now, I did mention to you about AML, CML, and I know the rest, CLL and so on. So this is a good example. I thought I should show it, but we're going to look, the next video, of course, I'm going to be presenting blood film and telling you what it means. And we're also going to be looking at differential diagnosis or test we can do to confirm that, okay? So, but on this occasion, I want you to look at this. Look at a lot of white cells here. Some are matured, some are immatured. But look at this one again. A lot of white cells, mostly matured. Once you see a lot of white cells, please start thinking about chronic. That's what has happened here and here. So this is CML, chronic myeloid leukemia. And what is a strong indication? There's mature neutrophils, there is immature neutrophils, there is myelocytes, you know, and so on. So they are all here. But look at this AML. It is mainly blast. So that's one of the things I'm trying to tell you, that when it comes to CML, you may not even see any blast. If you see, the percentage will be very, very low. But when it comes to AML, definitely it's going to be a lot of blast. Okay. The same thing is applicable in ALL. Okay. You can see all this is mainly blast. Okay. But then when you look at the CLL, just mainly matured lymphocyte. So that's why I told you when it comes to CLL, or maybe when it comes to CML, the total white cell count will always going to be high. And then you need to look at the differential count and find out what is high again. Then, and if you look at the blood film, you can justify that better. So this is a good example of maybe CLL, AML, and so on. Okay, that is it for me. I don't know if you have got any question. If you do have any question, please put it on the comment. I am happy to answer those questions, maybe in the next video or something like that. You put your comment. Like I've said, I keep making this video to assist all of you to get your dream job, either as a biomedical scientist or specialist biomedical scientist. These videos will help you. I want you to do your best to watch it to the end, because then you can be able to understand everything. I'm not trying to rush my answers, because I believe if I give you detailed answer, it can enhance your understanding to be able to give good answer when you go for your interview. Once again, my name is Dr. Emmanuel Obodo, okay? And I've been working in an NHS hospital as a specialist biomedical scientist, and I'm also a lecturer in biomedical science here in the United Kingdom. Please, can I ask you to continue to subscribe, comment, and like, and share to your friends. Thank you very much. Till I come your way again. Bye.